My name is Josh Stamper. I'm the Irrigation Extension Specialist. Here at I've got a split appointment between soil, water, and climate and biosystems and bioproducts engineering. If it looks like I slept in these clothes, it's because I did. I just got back from saturating neutron probe access tubes about an hour ago. So I'm a little bit behind and late on things. Most of my work is interacting with agricultural producers that use groundwater for supplemental irrigation. I don't have the traditional responsibilities of a lot of the faculty here. Mostly I work on the kind of applied sciences, fast and dirty soil physics, bucket and barrel chemistry, and I sponsor a over-irrigators anonymous support group. Most of the folks that I work with are farmers and crop consultants, and helping them understand, what's the basis of good irrigation water management. When you start talking about soil physics, I'm sure most of you had that experience when you were an underclassman. You went into Satish's class, and he started talking about things, and you could see the fear welling up in your cheer's eyes. That's what farmers encounter all the time. We talk about, we're going to talk about, tension, and we're going to talk about centibars and kilopascals, and they glaze over. So a lot of my work is really working with them on how do we help them, how do we simplify a lot of these concepts and put it into terms that they can understand. I supervise Josh Cook. Josh worked with me last year on a project with validating variable rate irrigation prescription maps. He's a ArcGIS guru, has worked a lot in geographic information systems, and then I have an assortment of undergrads that run irrigation technician positions. My interests, I'm really interested in the interaction and relationship between nitrogen uptake in crops and soil water status. I'm really interested in lysimetry. I work a lot with different types of lysimeters, from steady tension lysimeters to zero tension pan lysimeters to suction cup lysimetry. I'm really also interested in what we refer to as easy button technology, tools to take to a grower and say, boom, we can make this easy. I spend a lot of time thinking about how do we simplify complex scientific concepts. And sometimes that means oversimplifying. But if I can get guys, if I can get farmers, and not just guys, men and women who use irrigation water, if I can help them understand some of these concepts, we can gradually up their level of management. One of the goals of this is to get folks to understand a soil water characteristic curve, and specifically soil water characteristic curves that are specific to the soils that they farm and they irrigate. If we can get them to understand what is field capacity, what is the permanent wilting point, what is the volumetric water content, and how does volumetric water content change with tension. That's a relatively simple graphic that I'll show you guys later, but it's really important, and it really defines how we mine water out of the profile. Work with a lot of state agency staff. Sometimes they don't always have real good comprehension of how the engineering around irrigation works, and then come up with tools that don't suck. So this is just real quick a flyover of some of the work that we've done in Minnesota, where we came in using the DNR's database about where groundwater gets appropriated and how it's allocated to people. And then we would, with the DNR data, it's just point of taking. It shows you where wells are. But then we actually came through and we delineated every center pivot irrigation system, whether it had a permit or not. And then we mapped it out and we created an ArcGIS database. And we've used that, we've made it available to some of the consultants that have worked on irrigation scheduling tools, and it also helped us prioritize what are the most heavily irrigated soil types in the state. In Minnesota, that's going to be our number one most heavily irrigated soil type is a Hubbard, and then it goes down to Verndale, Esterville, and we move down a hierarchy. So some of the stuff that we work with is training, extension, and SWCD staff. In this instance, we're using time domain reflectometry and smartphone applications to map spatial soil moisture. We work with SWCD technicians and farmers. and then cataloging and compiling some of this information.